And in this particular session of our ACCA P3 course, we'll be continuing with what we were looking at in the previous session, which is, if you remember, we started talking about the numbers. So we started talking about management accounting. So what we've done so far is we've talked a little bit about variances, we just did a little bit about them. We also, the big thing was we talked about decision making. We spent quite a long time looking at Ray's question, NMS, from the pilot paper, and we discovered, this is a very common exam question, that Ray was making a decision. He had used a model in order to make that. He'd used a method, he'd used a technique, payback, in order to make his decision, and we had to think about whether payback was the best thing to do. And then we had to say, even if he did use payback, well, some of the numbers that he was putting in, some of the things like, for example, the energy savings, which was just a guess, would mean that it didn't really matter what numbers, what method he used, his numbers probably wouldn't have been very accurate anyway. So even if he'd done NPV, because some of the rows he was just guessing at or being optimistic about would have been wrong anyway. We then had a look at some other marginal costing techniques. We had a look at key factor analysis, and we had a look at close or continuance decisions, and then we had a look at an exam question from 2013 where we saw that there were numbers that could be used to, fairly straightforward calculations, but numbers that could be used to support a decision. And the fact, of course, is that a lot of students didn't really do that. They simply said, you should do this, and they didn't give any monetary consideration. They didn't give any financial calculations at all, even though the examiner said that he wanted us to do that. So we will return to chapter 9 of the notes, and this is a question about special contracts or relevant costing, whichever one you want to call it. I'm not particularly worried. Now again, there is quite a lot to read, so if you want to read it first, pause the tape now and then rejoin us when you are ready. Right, I will assume that you have read it. The idea in this question in JB Limited is that we have to say whether the contract should be accepted or not. So in other words, this is a strategic choice. Is it suitable? Is it feasible? Is it acceptable? And we have to say yes or no to this contract. Right, okay then. So, first of all, relevant costs. Now, the big thing with this question is there's bits of it that you may well get wrong. There's one bit that nobody ever gets, and if you don't, it's about material P2. If you don't get that bit, doesn't matter. In the exam, if there's a bit you can't do, make a number up and move on. Right, we've got, first of all, material M1. Material M1, we need 4,000 kilograms, and it says material M1 is in continuous use. Future purchases will cost $650. It doesn't matter if we buy the material M1 or if we take it out of stock, we're going to have to replace it, and to replace it's going to cost $650 a kilo. So material M1, that's going to be 4,000 kilos at $650 per kilo, which equals $26,000. So that's the first cost. P2. Now again, don't worry if you don't get this, because I get asked this bit more than anything else. Right, P2. First of all, we need 3,000 kilograms. So let me just write that down before I forget. Now the question is, what is the relevant cost of P2? Right, the original cost was $350. That is a sunk cost. It is not relevant. The second thing you can do, you can say it's been written down to $1.50 scrap value. So you could simply sell it for $1.50. Remember, you already own it. You could simply sell it for $1.50. Or there is an alternative. You could use it as a substitute for P4. If you do that, you have to spend an extra $1.60. Buying P4 costs you $4.60. So, if I turn it into P4, I don't have to buy P4, which means I don't have to pay $4.60. But it costs me, I've got this P2 anyway, I've already bought it. It's going to cost me an extra $1.60 to do that. Now, it's your choice. Which would you rather do? Would you rather take the material that you already own and sell it for $1.50? Or would you rather take the material you already own, you've already paid for it, and turn it into P4, I do apologise, and save $3? Well, you're obviously going to do that one. It's better to save $3 than it is to receive an extra $1.50. So, the relevant cost there is $9,000, because obviously if we use it on this project, we can't do either of those two things. You then have I think it's called part 678, if I remember correctly. I think it's part 678. This one's nice and easy. It just costs you $80,000. So that's nice and easy. 80,000. Now you get your labour. And your labour that you have, you've got 3,000 hours of skilled labour, 4,000 hours of semi-skilled labour. Again, I'm afraid I'm going to have to write these down one bit at a time. So we've got 3,000 hours of skilled labour, and I think it was 4,000 hours of semi-skilled labour. Skilled labour can be hired for $8 an hour. Semi-skilled, idle time, $5 an hour if they're being paid. So 3,000 hours at $8 each, $24,000. Semi-skilled labour, I hope everybody is happy with the idea that what I've just done there is incorrect. And the reason it's incorrect is there is idle time. So if you get the workers to make this item, you don't pay them anything extra than if you pay them to sit around doing nothing. There is no extra cost. So the cost, the relevant cost for making this item is $0. Okay then, hopefully that's still okay. And then we have our overheads. We've got 40,000 machine hours, and then we've got $7 an hour is variable and $13 an hour is fixed. So we've got overheads, we've got variable overheads. What did we say? We said it was 40,000 hours at $7 per hour. Fixed overheads, we said it was 40,000 hours at $13 an hour. So that is $280,000 of variable overheads. And hopefully again, you are okay with the fact fixed overheads will be $0. Why will fixed overheads be $0? Because fixed overheads are fixed. Whether we do this contract or not, the rent bill on our factory is not going to change. So remember, relevant cost about the cost that change. The fixed overheads don't change. You may have more money to put towards them, but the cost you're going to have to pay doesn't actually change. There is one other bit, however, that will change. Down at the very bottom, it says we're going to get fixed costs will increase for the duration of the contract by $300,000. So we're going to get $300,000. So we get another row of fixed overheads, 300,000. If we add all of that up, 580, 604. I should actually, it comes to, I know what it comes, don't know why I'm adding it up because I know what the answer is. It comes to $719,000. I know that number's correct. So the question is, from a financial point of view, should they accept the contract or not? Now, virtually everybody gets the wrong answer. That virtually nobody gets 719. It happens occasionally, but it doesn't happen that often. It's usually the P2 that's the problem. Now it says a price has been suggested of 720. So, your cost is 719. Your sales price is going to be 720. So the question is, should you say yes or no? Now, this is where we start moving into yes because, no because. One answer is better than the other, but they are both, in many ways, they're both correct. You could obviously argue that it makes a profit of $1,000. And if you think about how many items they're going to make, it says they're going to make 120 items a month for the next 5 years. So they will make $1,000 profit for each plane. They're making a component that goes into the plane. But they'll need 120 components a month, 12 months a year, 5 years. That's going to be something like, I think that's something like $7.2 million profit that they will make. You know, that's pretty reasonable. But what most students will say is, forget the profit, look at the margin. Profit is 1,000, sales price is 720,000. That's something like I think it's something like 0.014%, something like that. I'm used to having, I'll be honest with you, I'm sorry about the numbers, but I'm used to having people watching this in the classroom or live who can actually tell me what the numbers are. I'm not used to having to do it on my own. I think it's something like that. It's a tiny, tiny, tiny margin. Is the reward of making a 0.014% return, is that worth the risk of it going wrong? And I would say no. I would turn it down, to be honest with you. So I personally don't think it's acceptable, although there are some students who say, it's still $7 million you're going to make. But remember, I did say to you, we also have to think about, is it suitable? We have to think about, is it feasible? Now, let's actually look at the company. JB is a small manufacturer. And they are going to be asked by REL, they're going to have to manufacture 120 units a month for 5 years. Will they actually be able to do that? Is it feasible for them to actually do it? Do they have enough money? Do they have enough staff to be able to do this? And I think the answer might well be no. Remember, it's going to cost $7 million to make one of these. So it's going to cost $700,000 to make each of these things. They're going to need something like 700,000 times 120, call it times 100 to make it easier. They're going to need something like $70-80 million in the first month to be able to pay to make these things. Okay, they all get given the money back from REL later on, but can they actually even physically do it in the first place? Is it feasible? You could also argue, is it going to be suitable for them to do? Because REL will end up being a very, very, very powerful customer. JB will probably rely on REL because they're going to be making so many things for them. Do they want a powerful customer? What other things could JB be doing with their time? Instead of making things for REL, perhaps they could make things which got a better profit margin for themselves. Not only that, REL is actually a new company. It's a new entrant to the industry. What happens if REL go bankrupt? It will probably make JB bankrupt as well because they won't be getting the money for having made the components. They'll have to pay their suppliers to build the components, and if REL go bankrupt, they'll never get the money back. I think this is a really bad thing for JB to do. I would say no. I don't think it's acceptable. I don't think it's suitable. I don't think it's feasible. Now, there is one thing I should point out to everybody. I've been slightly... I haven't lied to you, but I've not made a big fuss about something. I said that the cost was 719. That's not true. The cost of the first unit is 719. Because after that, the cost will change. You told me, or you would have told me if you were here, that the labour cost for the semi-skilled labour should be zero because there's idle time. That's for the first item. maybe the second, maybe the third. Are you telling me that there's going to be 5 years of idle time? At some point, those semi-skilled workers have to go back in there again. So this 719 is actually only the cost of the first one. The 300,000, that could perhaps just be a one-off cost that never comes back again. So it may well be that actually they make more than $1,000 for most of the rest, and they just won't make it for the first one. The point behind this is that expect the numbers to be wrong. If you get to do a calculation like this, expect that you will get something wrong somewhere. Nobody ever notices, hardly anybody gets a 719, and nobody ever notices actually it's only the cost of one of them, not all of them. I don't actually know what the cost of all of them is going to be, because it will depend when the semi-skilled labour runs out of idle time. It depends if this 300,000 is per year, one-off, I don't know what it's going to be. What I would do is I would expect that I'm going to get the numbers wrong. So I wouldn't worry too much about P2 because I think my numbers are going to be wrong anyway. Just get a number and talk about the number. The other thing I would say is when I do this question, I say to students, where did you start? And they all say, I started with material M1. I say to all of them, why didn't you start with that bit? Why didn't you start about whether it's feasible and whether it's suitable? Because you can do things like it's going to be a powerful customer. You can do things like they've recently entered the industry without doing any calculations at all. So you don't have to start with the numbers. Yes, do them, but don't start with them and expect that you've got them wrong anyway. So there's no point in worrying about, have I got that absolutely correct? Because the chances are, no, you haven't. Don't worry about it. So, special contracts, relevant costing, it's part of decision making. I'm not going to worry about 8.5. We've seen 8.5 before. We did that back in chapter 1. We looked at liquidity ratios, we looked at gearing ratios, we looked at profitability ratios. We've done all of that already, so I'm not going to worry about doing it again. It's only in chapter 8 just to remind people we've already seen it. And again, all the rest of that chapter you can read for yourself. Let's instead move on and talk about chapter 9. Chapter 9 is not doing management accounting as such. What it's doing instead is it's forecasting. Now, you may remember back in chapter 3, we talked about scenario planning. And scenario planning was a way that you could try and forecast what the future is going to be. So I just get me back again. So in chapter 3, we talked about forecasting. We did scenario planning, and scenario planning says, let's identify the key things in the outside world that will affect us. And then let's say what could happen to them. So you could have a law that's going to affect you. Is it passed or not? You could have new entrants will affect you. Will they come in? Will they not come in? So in other words, you can think about what the key things and what might happen. You then say for each of them, if this happens, if the law is passed, we will do this. If the law isn't passed, we will do that. If a new entrant comes in, we will do this. If a new entrant doesn't come in, we'll do that. You come up with a plan for each of these scenarios. Now, the thing with scenario planning then, you have no idea how likely these scenarios are. You can't say there's a 60% chance this will happen, because scenario planning simply says, let's think about what happens if it does occur. It doesn't do probabilities occur. Doesn't do probabilities at all, sorry. So if a new entrant comes in, a new entrant comes in. We don't work out the likelihood of that. In other words, there's no numbers in it. Chapter 9 starts talking about numbers. We start putting numbers in and try to quantify things, to try and work out how likely they are. Now, there's only 4 topics in chapter 9, all of which you've done before. Regression, time series, expected values, and decision trees. These top 2, you won't have to do any calculations. They take too long to do the calculations, so you'll simply be told, you'll actually be given the regression, you'll be given the time series. Expected values and decision trees, you may have to do the calculations. You have been asked to do them in the past, but they've been very simple. They've been very straightforward calculations. So let's have a look. Blah, 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 blah. Regression analysis. The idea behind a regression analysis is very simple. We use the past to predict the future. That's all that it is. We use the past to say that we can predict the future because there is a straight line that connects what's happened in the past to what's going to happen in the future. And we can use that straight line to predict the future. Now, the example that you guys would all have had when you were doing F2 and probably F5 is you would have had units and you would have had total cost. And the idea is the black crosses that are on the screen represent the past. I have kept a record of how many units I made in the past and how much it cost me altogether. And I use that to predict the future. And I do it in two ways. First of all, I work out the gradient. The gradient, very straightforwardly, simply means what is the increase in y if x increases by 1. If I am doing total costs and units, and please, that is only one example. Most examples in the exam are not total cost and units. But if I was doing that in the exam, it would mean if I made one more unit, what would happen to the cost? And B, what will the cost go up by? Well, obviously, that's going to be the variable cost. So if you make one more unit, you have one more unit of variable cost. That's what your total costs go up by. That's what B represents. A is the value of y if x equals 0. Now again, if you are talking about units and total cost, that would mean if you make no items at all, x is the units. If you make no units at all, the total cost, how much will you spend? That's going to be your fixed cost. Again, please, please, please remember that is just one example. In a minute, we're going to have a look at an example which has got nothing to do with variable costs at all. Students still insist on calling them fixed and variable costs. So you're going to use the past to predict the future. So the idea is next month, I'm going to make that blue cross. I'm going to make that number of units, and I can put in that as the value of x. I can work out what A is, I can work out what B is, I can use it to predict how much I will need to spend next time. So you can forecast the future. Now, R squared basically is saying you can always do a straight line, but will it be of any use to you? So here's two examples. I've actually got the same straight line, or near enough. Example number 1. The dark grey crosses represent the past. Those crosses, the line goes very close to all of them, so that means that my prediction is probably going to be pretty accurate. The R squared value would be close to 1. Now, on the other hand, second example, I can still work out what the straight line is. There is still a value of B, there is still a value of A, because there is always one. But you can see, to predict the future, that line's going to be hopeless because it doesn't go near any of the crosses in the first place. For that one, the R squared is going to be basically 0. The cut-off point, don't ask me why because I don't know, is R squared is about 0.8. If it's bigger than 0.8, the line is useful. If it's less than 0.8, the line is basically not telling you anything. It's a line, but it's not going to predict the future at all. Now, let's have a quick look at example 1. Example 1, it says, here is B. I'll do them in the same colours I did earlier, actually. There is B, there is A. In other words, the examiner has done all the calculations for you. And what you have to do is you have to say, what does it mean? This is a typical exam question. The examiner's done the answer, you just interpret it. So, what does it mean? Right, B is 6. That means that if X goes up by 1, in other words, if marketing goes up by $1,000, because it's in thousands, if X goes up by 1, what happens to Y? Sales go up by 6,000. That's what it means in this question. Notice I'm not talking about variable costs or fixed costs. That was only if you've got units and costs. Here we've got marketing and sales. So if you spend an extra $1,000 on marketing, you get an extra sales of 6,000. That's what the B means. What does the A mean? The A means if your marketing, because that's what X is representing, if your marketing is equal to 0, then you still get sales of 480,000. That's what the A means in this example. So if marketing is 0, if X is 0, if marketing is 0, what's Y? What's the sales value? The coefficient of determination is fairly close to 1. It's bigger than 0.8, so this is a useful thing for us to be able to predict. How do we use it? We can forecast sales. If you spend no money at all on marketing, you still sell $480,000 worth of sales. And on top of that, every time you spend an extra $1,000 on marketing, you get an extra 6,000 sales. We're going to spend $100,000. So that's going to be 6 times. What have I done wrong there? There we go. I didn't say I couldn't think of it for the sake of it what I was doing. So you're going to have $100,000 of sales. You're going to have $100,000 extra of marketing. Each of those is going to bring in $6 worth of sales. So in other words, we will end up with 1,080,000 altogether. Another way I could have said this top one, B, marketing goes up by $1, sales go up by $6. Same thing. So we spend $100,000 on marketing, that's $600,000 of sales, and we would get $480,000 anyway, even if we did no marketing at all. So take the 480 and add on 600,000. What about the second one? The second one looks the same. Right, 480,000. It's fair enough. Plus 6 times 250,000. That gives me $1,980,000 worth of sales. Now, it looks a bit strange that you've been asked the same question twice. And the reason is because one of them is right and one of them is wrong. The one that is correct is the first one. The reason it's correct is because when we were using our straight line, we wanted to work out what happened when we did $100,000 of marketing. And we were basing it on the range of values was 40,000, that was the lowest, up to 120,000, that was the highest. And our 100,000 is in the middle of that. So we've got a fairly accurate idea of what's going on. What about the second one? The second one says, what happens when you spend $250,000? I have no idea. I don't know what's going to happen when you spend $250,000. The most I've ever spent in the past was less than half of that. How do I know what's going to happen when I spend $250,000? I don't know anything at all about that. And this is a very good example of what the examiner does. Mathematically, they are both correct. The trouble is, one of them has been used inappropriately. You can't actually do the second one. You don't know what's going to happen. First one is fine. So from a maths point of view, the calculations have been done fine, but one of them you just can't do the calculation at all. So, linear regression. Time series I'm not really going to worry too much about time series, to be honest with you. You won't ever have to do it in the exam. What you might have to do, however, is to explain what it means, or to explain how it's really to explain what it means. Now, at the end of the notes in chapter 16 are the answers to all of the examples that we have throughout the entire set notes. Now, most of those examples are chapter 8 and chapter 9. This is from the pilot paper, and the examiner's answer is in there. So you can actually see how this works. The idea basically, and I don't intend to spend very long on this, is, again, we're trying to predict the future. So what we do is we take, in this case, the first 4 quarters, 56, 70, actually, no, I'm lying to you. No, that's what we do. Sorry. Confusing myself. We take 56, 70, 74 and 60. So I thought I'd been put in the wrong place. And that adds up to 56, 126, 196, 196, 200. That adds up to 260. And then we move down a row. We move down a quarter. I then add up the next 4 rows. Now, what I've done is I have lost quarter one of quarter one of 2006. I've replaced it with quarter one of 2007. So there's always one of each quarter being added up. And I add these ones up now: 70, 74, 60 and 60. 70 and 60 is 130, that's 190, that's 264. Then I add those two together and I get the 524. And that's all you do. You just go down again. So the next one down, we would add up 74, 60, 60 and 80. Add that to the 264, we'd get 538. And we just do that all the way down. That 524 is made up of 8 numbers. So you divide by 8 to get that column. 65.5. 524 divided by 8, 65.5. 65.5, that's how many units we should have sold in quarter 3 of 2006. But we didn't. We sold 74. So in other words, the value of C, what you actually sold, minus what you thought you would sell. 74 minus 65.5 is 8.5. 60 minus 67.25 is minus 7.25. And you can keep a record of these for each row that you've got. So the variation is what happens each time. It's different to what you thought it would be. And the thing is, there's a pattern. So what you then do is you say, right, let's just highlight quarter 3. So we've got that one, and that one. Put them in a table. Work out what happens on average. On average, you have 7.5 above what your trend should be. If we have a look at quarter 4s, minus, minus, minus. We put them in a table and we say on average in quarter 4s you sell less than the trend. In other words, there is a pattern, the seasonal variation. Now, for reasons that I don't really want to get into because it's too complex for what we need, these 4, if you do this for each of the 4 quarters and you add them up, it should equal 0. And it doesn't. It's above 0. So what the examiner has done, I wouldn't have actually bothered doing this, is the examiner has taken away 0.58. They add up to 0.58. He's going to subtract that. And what he will do is he'll subtract 0.58 divided by 4, because there's 4 quarters. He'll subtract that from each of those. So you get minus 11.5 minus another 0.15. 9.17 minus 0.15. 7.5 minus 0.15 minus 4.58 minus 0.15. So he simply takes the averages, and then to make it all add up to 0, he says, what do I need to get rid of in total? 0.58, share that divided by 4. That's just how he does it. The seasonal variations then, you can see quarter four, same number each time. And all that this residual bit is what's left. You had 67.25. You've said because it's quarter four, you'll be 4.7. Beneath that, you actually had 60. That's another 2.52 that's left over. So in other words, you've got 60. 67.25 was a trend. You're going to take away 4.73 because it's a quarter four. That leaves you with 62.52. Your actual was 60. The difference is still 2.52. That's where the residual figure comes from. Now, it's all explained in the answers at the back of the notes. The key thing is simply, can you use time series at all? Time series only works when you have these variations that repeat in a regular pattern. The examiner often does them when they don't repeat in a pattern. So again, mathematically, what he's doing is correct, but it's not actually telling you anything. So it's correct, but useless. So again, you don't have to do the calculations. He will do them all for you because it takes too long. I just thought I'd point out how it all works. The ones that you might have to do, you might have to do expected values and you might have to do decision trees. Expected values. The problem that we've got with time series and with, or the advantage rather that we've got with time series and with linear regression is we use the past to predict the future. What if there isn't a past? What if this is the first time we're doing something? We can't use linear regression because there's no past. We can't use time series because there is no past. This is the first time we're ever going to do it. So instead, what we do is we try and predict the future using probabilities. And this is where expected values come in. So we have got a company that's thinking about spending $30,000 to buy some equipment. And the trouble is they don't exactly know what's going to happen in the future because demand might be high, demand might be low. The chance that demand is high is 0.75. The chance that demand is low is 0.25. The trouble is they don't know what's going to happen. So I want to do an NPV calculation. I can put in 30,000 as an outflow, but what do I put in as an inflow? Because I've got two different numbers. So expected values say, look, we can work out what number to put in there as your cash inflow. All you do is take what's going to happen if demand is high and multiply it by the possibility that demand is high. And then what's going to happen if demand is low, multiplied by the probability that demand is low, and then simply add them together. And that gives us, I think if I remember correctly, that gives you 11,500. And that's what's going to go into the net present value, that one figure. And you just do that for the other ones as well. 13,000 times 0.75 plus 10,000 times 0.25. That, I think, that's an extra 250. I think that's 11,750. Again, the answers are in the notes. If I'm wrong, you no doubt will correct me. 13,000 times 0.75 plus 9,000 times 0.25, 11.5. And the final one, 14,000 times 0.75, 8,000 times 0.25. So that's, let's say that's plus 750 minus 250, that's plus 500. I think that comes to 12,000 exactly. And those are the numbers that you put in for year 1, 2, 3 and 4 in your NPV, and then you could discount them. I'm not going to do that, but you could then discount them. Now, problems with NPVs, or problems with expected values rather. We are saying that in year one, we will have income of 11,500. No, you won't. You'll have income of 12,000, or you'll have income of 10,000. You won't have 11,500. It's going to be 12 or 10. It won't be 11. So one of the big problems we have with expected values is you end up with an answer that you won't actually get. They will not get 11,500 in year one. They will get 12, or they will get 10. They won't get 11.5. So that's a problem. The other problem that your examiner likes to do in the exam is something that you really will only see if you actually work out the numbers. You will work out that if you do this, the NPV is something like, and I can't remember the exact numbers, it's something like plus 5764 or 5723. It's a positive number. So what most students say is you should do it. You should do that. You should do the project because the NPV is positive. The trouble is there is a 25% chance that demand is low and income is low. And if you just do that one on its own, the NPV is going to be negative. I mean, we could probably work that out fairly easily. 10, 10, 9, 8. The income is only 37,000 even if there was no discounting. And there will be quite a lot of discounting in there. The chances are it's going to be negative. And it turns out the NPV, if you have low demand, the income is negative, and there's a 25% chance that that's going to happen. Do you want to do a project? The thing is that if it goes well, it's very good. But if it goes wrong, it's very bad. Do you want to do something where there's a 25% chance that the NPV is actually bad? Most students say no. Now, doing the expected value hides that. So can I suggest to you, if you get an expected value question in the exam, look at just what happens if it's bad. Whatever it is, the income, demand low, whatever it is. Just look at that on its own. It's probably going to be a bad thing. Then do your expected values. And it will probably be, overall it's good, but there's a 25% chance it's going to be very bad. And that brings us to decision trees, which is the last thing that we're going to look at in Chapter 9. Decision trees. Decision trees are basically exactly the same as expected values. The only thing is that we have got, fairly obviously, we're going to draw a diagram about them. Now, we've got a question, and it says that we're thinking about building two different sizes of plant. Big plant, small plant. Now, if we decide I wouldn't normally do it like this, but I've realised I haven't got very much room. If we decide to build a large plant, then there's a possibility demand will be high. There's a possibility demand will be low. Small plant, possibility demand is high, possibility demand is low. Right, what happens if we build a large plant? Well, if we build a large plant, it says high demand, there's a probability of 0.7, and we will get 250,000 a year for each of the next 5 years. So we will get 5 times 250,000. Demand is low, we will make a loss of 50,000 for each of those years. You can use expected values to say how much we will expect to get altogether. Right, probability that you get high demand is 0.7, probability you get low demand is 0.3, and again I ought to be able to do this in my head and I can't, I'm afraid. So 5 lots of 250,000 is 1.25 million, 0.7 times that, let's see, 1.25 million, that's 125 times that. I can't remember the answer. I'm going to say 900,000. I'm also going to get myself out of the way so you can see that calculation. That's wrong, but I can't remember what the right answer is. This one, 5 times 50,000, it's negative. That's 250,000. 0.3 times that, I know that is 75,000 negative. I can do that one. And so the expected value, you add them together, you get plus 825. Let's say I know that number is wrong, but bear with me for the sake of the calculation. Small factory, we get 150,000 times 5. Probability that demand is high is 0.7, and we get 5 times 25,000. Probability is 0.3. Okay, so 5 times 25,000, that's 125. That, I think, is 37.5, that bit. 5 times 150,000 times 0.7 is... Oh, that's one. So 750 times that, again, round about 500,000. That's not the correct answer, but that's fine. Expected value is about 537. So remember, you add the two together. So we've taken the expected value. If demand is high, demand is low, we add them together. So if you build a large factory, you get more money. But a large factory also costs you $600,000 to build. So your net is going to be 225. So you're going to get 825, it's going to cost you 600,000 to do. Now I know that's wrong because it should be, I think it should be 200 if I remember correctly. Your small factory costs you 350. You're going to get 537. It's going to cost you 350. So that means that you'll end up with 187,500 as your net. And again, I know that's wrong because I know the small factory is actually better than the big factory. So, in my example that I've just done here, which has got the higher value, the large factory, the actual correct answer is the small factory. And I'd say the answer's at the back of the notes. Do an expected value. Remember, you've got a cost in the first place. Lots of students forget that. And then you simply take whichever one is bigger. The expected values, the decision trees, they're not complicated. They're relatively straightforward to do. So the key thing with all of these then is to remember that the idea, I'll bring myself back again, that the idea is to think, is what you're doing useful? Is what you're doing actually helpful? So you could do a decision tree question and then it will often say, tell me any problems that you've got with doing the decision tree. If I just go back to what we've just done, the problem that we've got with the decision tree is you will not make 225,000 if you build a large factory. You will make 900,000 using my numbers, or you'll make a loss of 75,000, but you won't make 825,000 because it isn't going to happen. Yeah. Another thing, remember, big problem with expected values is it hides what's bad. Now, if you look at the large factory, there is a 0.7 chance that you make a lot of money. There's a 0.3 chance you lose money because remember, if demand is low, you will lose money each year and you will have spent $600,000 building a factory. You're going to end up losing 5 lots of 50,000, that's 250, plus the 600, you'll end up losing nearly $1 million if demand is low. And there's a 30% chance, a 0.3 chance that occurs. Lots of students would say, actually, that's too risky. I'm not going to bother doing it at all. But if you do an expected value, it hides that and it makes it look like it's a good idea. So that question, although, as I say, I know I got the numbers wrong, I'm not worried about that. That question illustrates the two big problems with expected values and decision trees. You come up with an answer that you can't actually get in real life. And secondly, it can hide what happens if it's bad. Now, there's obviously a third problem as well. What if the probabilities are wrong? Now, it wouldn't take much, again, particularly in the real answers, I know I've got mine wrong, but particularly in the real one, it would not take much. The probabilities wouldn't have to change by very much to make the large factory better. The small factory is only very slightly better in the correct version. So if high demand was maybe 0.73 and low demand was 0.27, the large factory might end up turning up better. And remember, these are probabilities about the future, so they're guesses anyway. So if my guess is wrong, it's not 0.7 and 0.3. If it's something different, if it's 0.8 and 0.2, the large factor is better. I've made the wrong decision because my probabilities were wrong. So the three problems then, you don't get the actual answer, it can hide what's bad, and your probabilities are guesses. If they're wrong, you might still make the wrong decision. Be aware of that, because one of the things the examiner often says is comment on your answer. And in an NPV question, or a decision tree question rather, part of your comments are going to be those three things I've just said. You've come up with an artificial number, you've hidden the fact this is what goes on if it's bad, and you're guessing at the probabilities that might be wrong. Now, what we'll finish with in this section is a question from the December 2014 exam called Noble Pets. And most of the Noble Pets question is actually a value chain question, because part A says evaluate the strengths and the weaknesses using the primary activities of the value chain. Now, we talked about that when we did chapter 5. I'm just going to look at part B. Now, it turns out in part A that again, having said I'm only going to look at part B, one of the things that you identify in part A, they have a strength, which is they have a very good brand name. You can see here also it says Noble Pets has a market share of 30% of the moist dog food market. So moist food as opposed to dry food. Dry food is basically biscuits for dogs. Moist food would be things where you have what you and I might think of as dog food, where it's some kind of pate. I only know this because we have a dog and he actually likes moist dog food. But Noble Pets has a market share of 30% of the moist food market. Okay then. And then you're given some numbers. Okay, so it says the consultants have identified the following information. They have done some past years, they've looked at some past years, and they want you to tell us what the numbers actually mean. Well, one thing that you can see fairly obviously is that moist pet food is going down at the same time as dry food is going up. So in other words, the market for moist pet food, which is what Noble Pet Foods does, we have a market share of 30%. This market is in decline. Dry pet food is growing. But the trouble is that Noble Foods don't really do dry pet food. They're in the wrong industry. So maybe one of the things that they perhaps should do is to think about changing from making moist food, maybe to start making some dry food. Now, something else, although it's in decline, towards the end, sales aren't going down very much. So they start off going down quite a lot, 370 to 350 to 330, but towards the end, they're not going down very much at all. So maybe, just as you can have maturity, maybe it's declined and it's sort of going to stay at the same level for a while. A lot of students said stop selling moist food at all. Well, there's still quite a lot of sales there. We've got 30% of that market, so that's worth saying. Similarly, although dry pet food is growing, you can see the growth is definitely slowing down. So moist food is probably there, dry food is probably there. Something that a lot of students also did was if you look at the total, if you look at how much is being sold altogether, if you look at how much pet food is being sold altogether between the two of them, the total is relatively constant. It doesn't stay exactly the same, but it doesn't change very much. It goes up a bit, it goes down a bit, but it's staying fairly constant. So what do the numbers tell you? Analysing trends in the pet food industry, there is a move from moist food towards dry food, although it looks like that's pretty much finished. There is still demand for moist food, and it's not a lot smaller than dry food is. The total overall is staying about the same. Now, what's the implications for Noble Foods? They should maybe look at changing one of their factories towards making dry food, maybe two of them, but certainly they should look at changing one of them. Now, part 2, forecast demand for moist food for the next 3 years. Right, how do we do that? We know that moist food is Y, X is the number of years that we've got. So how does this work then? We want to work out what Y is. This is the equivalent of working out sales in the example we had earlier. We are told the value of A is 369.5714. And then, for every time that X goes up by 1, in this case Y is going to come down by 9.86. Now the question is, what we're going to multiply that 9.86 by? X is looking at the number of years since we began. So we had year 1, 2, 3, 4, 5, 6, 7. 2014 would be year 8. So we simply multiply that by 8. And that will tell you what your expected sales of moist food are going to be in 2014. Now again, I can't remember the exact number. That's about 80. Something, it's about 291, something like that. 2015, 281, 2016, about 271. It's coming down by about 10 per year. So I forecast demand for the next 3 years. So I do 2014, 15, 16. I'm not going to do them, but it's exactly the same idea. The only difference is you'd increase that value of X each time. But the question also says, comment on the validity of what we've done. Now remember, linear regression says this is coming down in a straight line. But it isn't coming down in a straight line. We've just said that. It's actually coming down very fast and then slowing down. It's actually doing something like this. It's gone down quickly and is now slowing. So this is a good example of the examiner using something, and what he is doing is correct mathematically, but it may not actually be valid. So the answer you're getting may not actually mean anything. The other thing that we should just double check, we've got the value of R, but if you remember, we needed the value of R squared. The value of R squared is still round about 0.9 something, so that's okay. In the past, that's a little trick that he's done. He's given you the value of R as 0.8, and students have said that's okay, and it's R squared that needs to be 0.8. If R is 0.8, R squared is 0.64. So he's actually done something where there isn't that much of a connection. In this case, the R squared is okay. The trouble is it isn't actually a straight line. So we're predicting it's going to keep falling like that. And in fact, it isn't going to keep falling. So we're probably underestimating what's going to be happening in the future. So you notice you didn't really have to do an awful lot of calculations. Okay, you had to do those, but they're not complicated. What you had to do instead was you had to think about what it means. And that's the key bit from this session. Use the numbers to support something. This is a good idea because, or be able to say to the examiner, you have used that number and what you've done is not appropriate. You have calculated it correctly, but you shouldn't have done that calculation. You shouldn't have done linear regression in noble foods. It doesn't work. So yeah, you put all the numbers in, you've worked out B, but you shouldn't have done it at all. You're going to make the wrong decision because you're doing the wrong thing. Now, next session, session 6, we will move on to strategic implementation. We'll be looking at marketing. We'll be looking at business processes. We will start looking at business processes. We won't finish looking at them. But we'll start looking at them and we'll be looking at an example. We'll be looking at an exam question from December 2014. That's the same as the Noble Foods question. So again, just to warn you in advance so that you can prepare that if you need to. So we've now got to the end of the first 2 sections of the syllabus. We did strategic analysis, chapter 1, 2, 3, 4, 5. We've done strategic choice, chapter 6, 7, 8, 9. The rest, or the next 4 chapters, 9, 10, 11, 12. I said 9 again, sorry, I meant 10, 11, 12, 13, that's what I meant. They are all about strategic implementation. So we're going to look at marketing, processes and people. That's all coming up next. Until the next time that you watch this, good luck with your studies.